Hello class, I hope everyone is doing great when they start watching this video. We're going to start talking about renewable energy today, which is something I'm really passionate about, so I'm really excited to get to teach and share what I know with you guys. So, as always, we have some good questions to get us thinking about this kind of stuff. I'm curious if anyone can remember, we talked about the difference between renewable and non-renewable energy. So just if you guys want to think about that, maybe pause the video for a second, or maybe look back in your notes. What's our difference? And of course, renewable can be replaced quickly, while non-renewable needs millions of years, I should have said, of years to be made. So renewable needs a lot of time, non-renewable can be replaced quickly. And our types of renewables, we said, if you guys can remember, are solar, wind, hydro, geothermal, biomass, and even tidal. Tidal, something I don't know if we mentioned before, but another one. So our objectives by the end of our lecture is to be able to define and describe geothermal, hydropower, and biomass energy. We got a cool video which talks about each different type of renewable energy here. And then, of course, we'll be focusing on just a couple of them today, but we have already learned by this point about solar and wind. But the first one we're going to talk about today is geothermal. So I always like to break down root words. I think it helps remember what they mean. So geo means earth, thermal means heat. So geothermal means the heat from the earth. So anytime we see geography is the study of the earth. Thermal, heat, we learned about heat a little bit earlier this year. So geothermal energy is heat within the earth. The inside of the earth is very, very hot. Maybe you guys have learned about this before. We definitely learned about our different layers, or reviewed our different layers at the very beginning of the year, about how we have our crust, our mantle, our inner core, outer core. And we always said that this mantle is magma. This is what comes out of volcanoes. It's very, very hot. And so the idea is geothermal energy just kind of harnesses some of that energy, some of that heat, and makes it into electricity. But we can see there's all this heat from very natural geysers or volcanoes which release steam. Geysers release steam every day. Volcanoes happen every once in a while. But we can see this all around us, even at the surface of the earth. So yeah, geothermal just takes this heat that is already being released or made, and we use it. So I got to brag just for a little bit about Wyoming and Yellowstone National Park. So if you guys don't remember, I'm from this state in the United States called Wyoming. And Yellowstone National Park is one of the coolest places, most unique places in the world even. But it's one of the best places for geothermal energy. And so that's because it sits on top of an active volcano. So you can see a lot of energy coming to the surface, especially in the form of hot springs, which is, we can feel, it's like, almost like if you sat in a pool that was warm. So if you can imagine like warm pool, that's what a hot spring is. And then a geyser is a hole in the ground that shoots out steam and water, because it's so active, like the volcano is so active. So there's this cool video I'll post in our Google Classroom in the same place as always that shows some of the beauty, a lot of those geysers of Yellowstone. You can see lots of different animals, lots of different forest and plants and all sorts of cool stuff, but it's actually right here in the United States. So just in the corner of my home state, Wyoming. But the way geothermal energy works is there's a couple different ways to harness it. One way is to drill into the hot water under the earth. So we put a pipe into that and we let the hot water come up to produce steam. And then just like we learned for our non-renewable energies, that steam turns a turbine, which then turns a generator to make electricity. Then the steam goes into a different pipe to get cooled down, and then we actually will put that water back into the earth. So we're not really taking any water out of the earth. We're putting all the same water, the amount, back, We are just using the hot water, cooling it down, and putting it back into the earth so that it can get warmed again and start the cycle over. But the real key is we're using the steam to turn this turbine. The other way it can be used is we're just using the heat from the ground rather than from water inside the ground. And we put pipes with water in them coming out of a house or a building. The cold water comes out of the house, it goes down. And as it goes back and forth in this kind of S shape, it heats up because the ground around it's really warm. Then eventually it makes its way all the way back to what's called a heat exchanger, where it'll change that hot water. All the energy from the hot water will get taken away and used to make electricity while the cold water comes back. So we have geothermal where we're taking water from the ground. Sometimes though, we're just using the ground because the ground's warmer than above. We can see snow up here, so that's another way that people can use this geothermal energy. Some of the pros with geothermal energy, like any renewable energy, it's free energy. It's also super reliable. So this is something that is not always common for renewable energies, but because the earth is always going to be warm, is always going to be producing energy, making energy, it's reliable. So that's one important thing about geothermal. There's also a relatively low environmental impact. So some of their other things, other types of renewable energy can actually cause a bit of an environmental impact, not as bad as some of our oil, gas, or coal, but there is very low environmental impact for geothermal. The cons is it depends on the location. We need somewhere that is near a volcano or is very warm for the type that has the water, so it can be dependent. And then there's always a question about running out of that water that gets pushed up through. So lots of tests need to get done to make sure that we're not overusing our geothermal energy. The other thing, like a lot of our renewable energies, is that it has a very high upfront cost to build and drill into the ground, build the buildings and the heat exchangers, the turbine and everything. So it can cost some money. All right, hydro, let's look at our roots. So hydro means water. So hydropower is just energy made from moving water. This takes advantage of a lot of rivers, waterfalls, and even humans making large dams, and uses the natural process of the water cycle to make energy. So yeah, powered by the water cycle. It's been used for many, many years. Recently, we've been using it in a different way. Before, what people used to do is what is called a water wheel. So they would take a river and they would just divert a little bit of the river to go to move this wheel, turn this wheel around, and then once inside that wheel or that rotational energy, that shaft that's turning, can be used to grind corn or do all sorts of things. So water wheels have been around for many years. Now we're just using it with a turbine instead of a water wheel to make electricity from that. So this idea is the same as a lot of other processes we've seen. We're going to take water, we're going to push it through a turbine. The turbine's going to spin, and that spinning is going to make the generator make electricity. So this is the idea. We're using this difference in height. We can see this would be taller, a lot taller usually than down here, so that the water will come faster. If we have a big difference in height, if we're going 100 feet difference, it's going to produce a lot more energy than if we only had 10 feet difference. So that's how we are able to use water, and just water naturally wanting to run down to turn this turbine. Some of the pros for hydropower, again, free energy, there's no pollution. The nicer thing though too is it's very easily controlled. So if we want just a little bit of water, we can close some of these gates. If we want less energy, we can close some of the areas that are being used to turn our turbines. If we want more, we can open them all up. We can close half, we can close all of them. If we don't need any energy, like maybe in the middle of the night. So it's easily controlled. It's also helped stop flooding. So the idea is we have to build dams, these big concrete dams, and if it floods, if there's a lot of water or rain, it still gets collected above. So there's always enough room to help against extra water and flooding. Our cons is it can stop some fish from swimming upstream. So if a fish is down here, it can't make it all the way up here. So we got to find ways to solve that. Like a lot of renewables, it has a high upfront cost, and it also depends on location, just like our geothermal. We can't do this in the desert because there's no water out there, or also it makes more sense to be doing this at higher elevations, higher where we're farther away from the ocean so that we can have that change in height. Our last one we're going to just briefly talk about is biomass energy. Biomass energy is waste burned to make power. So biomass comes from any plant waste, like cutting trees or farming, and it's used like a non-renewable energy and is used to burn, or you burn it to make steam, just like we would a non-renewable. Some of the things that go into this word biomass are bio meaning life, right? So life, anything that used to be living or has mass, kind of weight to it. So things like wood, if we're chopping down trees, if we have extra stuff from our crops, maybe like our corn, we just eat the top of the corn so we can get rid of the bottom part, called the shaft, and use it for biomass. Landfill gas, alcohol fuels, garbage. This is all different kinds of biomass. We have bamboo, flower, sunflower, it looks like, some different flowers. This is just wood. So there's lots of different things that go into biomass, but it's all stuff that would have been thrown away or waste product anyway. So the way this works is we can put our wood, whatever we have, our biomass, into here, and it burns. So like we've learned in our combustion reaction with air and oxygen and then some kind of carbon, we can burn it and we would make CO2 and H2O. So we're going to make our gas, our very hot gas, which goes into our boiler. That hot gas then will take liquid water. The energy from the hot gas will make liquid water into steam. The steam turns our turbine, our generator, then makes our electricity the same way. And we have a little condenser so we can go from our gas to our liquid, and we can continue this cycle, and it will continue happening as long as we keep putting wood or something to make this hot gas. So looking at our pros versus cons, our pros would be it uses things that would have already been thrown away, which is great. So rather than ending up in a landfill or even worse in the ocean, we burn them to make energy. So that's great. It is cheap because we would have thrown this away. It's garbage. It's literally garbage. So that's nice too. The cons is there is some pollution like our non-renewables. We still are producing CO2, which is not great. It's also not super scalable, which by that I mean we can only put in as much of our trash as we have. So by scalable, for example, if we have a solar panel, we can just keep putting more and more solar panels and we would never run out of energy from the sun. We will eventually run out of biomass. Maybe not. We produce a lot of waste as humans, but the idea is at some point we would produce, or we would not have enough resources, enough biomass, enough trash to produce the electricity we need for everyone. So it's not scalable. So we need to use trees or crops, which we can't cut all the trees down in the world either. So that's what I mean by not scalable. There's a really cool last little bit of Wyoming stuff for you guys. Sorry to put this in here. I'm just really like to talk about where I'm from, which is a great place to live, a great state. This is about the Yellowstone volcano. So it's a cool what if video that I will post in our classroom as well about what if that volcano erupted, what would happen. So that is all I have for you guys today. If you have any questions, please let me know.